Hey there, Algebra 1. We got lesson 5-5. I'm going to be doing problems 1 through 10. Learning target, I can find midpoints and endpoints by graphing. I'm going to admit this lesson can seem kind of difficult, but if you stick with me, I promise you it's actually really, really simple. You're going to need these two formulas written down. They're going to show up on the test. You're going to want that in your notes. The midpoint formula is finding the middle of a line or some sort of distance. And what this says is x1 plus x2 divided by 2. That's going to be our first coordinate. y1 plus y2 divided by 2 is our second coordinate. You might be asking yourself, Mr. Blaylock, what in the heck is x1, x2? All that's saying is the first x, the second x. So you kind of see right up here, this is x1, that'd be y1, because xy, x2, y2. So for example, here they've given us two coordinates, and it says here is CD. Tell us what's the midpoint. So we're going to use these coordinates and plug them in here to our midpoint formula to solve. So first x is right here, -2. So we have -2 plus the second x. The second x is 4 divided by 2. It's going to be our first coordinate. Second one is y1. Well, the first y is -1 plus the second y, which is 2, divided by 2. That's going to be our second coordinate. -2 plus 4 is 2. So that would be 2 over 2. -1 plus 2 is 1 over 2. 2 over 2 is 1. So our coordinates would be 1, 1/2, or 0.5. That would be our midpoint for the line or array -2, 1, 4, 2. And again, all we did is plug these numbers in for this formula. That's going to be our midpoint formula. On the flip side, this one looks a lot more confusing, but again, it's just a matter of taking those steps. The square root of x2 minus x1 in parentheses, so we got to solve that first, squared plus y2 minus y1 squared. And basically all this is saying is it's solving the Pythagorean theorem, a squared plus b squared equals c squared in a formula. So here we got, again, that's our first x. This is our second x, first y, second y. So we're just going to plug those up in here. So we have the square root, make that nice and big. x2 would be 2 minus x1, which is -2. So I'm going to put parentheses 2 minus -2 just so we can really see that negative. That's all squared plus y2, which is -2, minus y1, -3 squared. Okay, now we just plug stuff in. Now we can actually solve. Well, 2 minus -2, we are going to add the opposite. So that's 2 plus 2, which is 4. So this is now the square root of everything, 4 squared, plus -2 minus 3, add the opposite. -2 plus -3 would be -5 squared. Simple enough. Hopefully you know 4 squared is 16. -5 times -5 would be 25. We have the square root of all that. 16 plus 25, and then we are going to take the square root. That's going to give us 35 plus 6, which would be 41. Square root of 41. And so our distance, if I were to flip back real quick, hold on, let me go back over here, would be, we can leave it as this. If we wanted to, we could actually put that into a calculator. I know the square root of 36 is 6, and I know the square root of 49 is 7. So I know this number has to be between 6 and 7, and it's about halfway. So we could say this is about 6.5 if I didn't want to use a calculator. But again, I am more than okay with this square root of 41 answer. Sometimes you're going to get an even number like square root of 36, but this is an acceptable answer. Again, these formulas, distance and midpoint, need to be in your notes. Please watch this lesson. I'm going to be completing problems 1 through 10. Zoom with me if you need help.